Okay, done. I guess we are live now. Yes. Sir,
Yeah.
you
So
can
first
continue.
of all, thank you, Risham, for introducing. I will start sharing my screen.
Sure, sir.
Yeah. Is my screen visible?
Yes, sir. We can.
Okay. So let's start the discussion then. So yeah. So our agenda for today's session will understanding the RCNN family for object detection. Basically, these RCNNs or all the members of this RCNN family are used for detecting the object from a given image, right? So we'll start with the brief brief introduction about computer vision. 1 second. Yeah, my voice is audible to all, right?
Yes, sir. It is coming nicely.
So yeah, we'll start with a brief introduction about computer vision, as object detection is an application of computer vision itself. So your computer vision is a field of artificial intelligence, your AI field, where that helps computer to understand the meaning or understand important information from images and videos. So basically, as the name is suggesting, computer vision. So just like as a human has a vision, human has eyes for knowing where the object is or seeing the things, we can also provide this particular information to our computer, and that particular field is known as computer vision. And how is that possible? If I give a brief idea about that. So just imagine you have taken an image from your camera, right? From your camera of the phone. Now that image is nothing but a collection of a data, right? So your image will be made up of various data points that are adjusted in a matrix format. So for example, you have taken an image that will have some space resolution. If you have seen, that will be of 800 cross 800 pixel resolution, right? So that pixel represent number of rows and number of columns. So 800 cross 800 means that your image is a combination of these 800 rows and 800 columns. So a matrix of 800 cross 800 uh, data points is there. And now these particular pixel, for each pixel value can be from 0 to 255. 0 will be your white color and 255 will be your black color. So in this way, you can assign numbers to your image. And this particular image format that I talked about, that was for black and white images. In colorful images, there are three channels: red, green, and blue. So combination of these three colors make a colorful image or make a images that we see. So again, here if I take a screenshot of this particular screen here, so basically the image that will be formed after the screenshot, that will be nothing but three different matrices for red color, green color, and blue color. And each point, let's assume it is of 1000 cross 500. So your 1000 columns will be there, 1000 columns will be there, and 500 rows will be there, right? And each point in this 1000 cross 500 matrix, there will be some value associated with each with that particular cell, right? One for red, one for green, and one for blue. And after the combination of all these three values, that particular image color, for example, if I'm talking about this particular image color, after the combination of red, green, and blue values, this particular image color will make. So in this way, you can represent an image in terms of numbers. And once we get numbers, as you already know, our computers works on numbers only, right? Basically, computer works on 0 and 1 binary system. But once we get the number, we will be able to feed that information to the computer, and computer will be able to understand your images. Now, taking advantage of these numbers, the pixel values, what we can do now, we can use data science also, right? Data science, machine learning, simple, if we talk about in simple terms. So we got the data for an image. Now we can do multiple things with it. We can do a classification, we can do an object detection, we can do segmentation, right? So I hope the computer vision thing is clear, that how computer are able to understand the images data, right? Now let's talk about different application of these computer visions by using your uh, machine learning or deep learning. Now, the first application is classification, image classifications. So just by providing the complete image and assigning a class to it. For example, our simple classification in terms of tabular data, how does it work? We provide different feature values, and then we provide a label value, right? For example, sorry. For example, let's take some classification example here. It can be anything. If I'm providing certain feature values and I'm providing it a class that, okay, it is, let's assume, let's talk about dog and cat images only, or dog and cat classification only, right? So in tabular data, if I'm providing that, okay, the color of the pet is white, or does it have pointy nose or non-pointy nose? How is its ears look like? If I'm providing all this data in tabular format and assigning a class to it, right? So I can train a classification model there. Now the similar thing can be done with the images. Now here your feature value will be the value associated with the pixel values that we talked about, right? And your label value will be whether the image is class or dog. So we will be providing the complete image there, or complete image data, pixel values there, to our machine learning, deep learning model, AI model, right? And it will give us an output that, okay, whether the class is cat or dog. That is your simple classification model. Now next comes semantic segmentation, one of the technique that is used in our self-driving cars. Tesla that is making, or whichever company is making self-driving cars, they basically use this semantic segmentation. So in this semantic segmentation, each pixel value each pixel value is assigned a class. For example, if you see here this blue one, so this blue one is sky, right? So each pixel value was assigned a class. So these particular pixel, or this particular pixel of the picture is of class sky. These particular pictures of the class of the images of the class trees, right? And these particular pixels of the image is of class grass, and this one is our cat. So each pixel is assigned a class value in our semantic segmentation. Next comes object detection. That is our uh, topic of discussion for today. So here, what happens in a given image, it will tell me that, okay, at this position an object is present. So classification is already happening in object detection, as well as image localization is also happening. So that particular thing is our object detection. And next one is instance segmentation. So in instance segmentation, only the object of my, let's say, interest is segmented out of the image. Here, if you see, there were these two dogs and one cat, and our object detection model was able to detect them, draw a bounding box there. Now, in instance segmentation, it will just take the pixels where these dogs or cats are just present. In this way, this instance segmentation is different from this object detection. So mainly these four main tasks happens inside our computer vision. Now let's get a little bit, let's see some of the example of object detection and how we can take advantage of this object detection in different industry. So from here, the first image you are able to see. Now, if I have trained a model that is able to detect that whether a medicine pill is missing or not, I will be able to know inside a medical store or inside a medical, let's say, industry, this medicine making industry, I will be able to know how my medical production is going on, or does in is it happening in packaging stage that some of the pills are missing, or some of the pills we are not able to put inside the complete tablet, right? So one of the application is this, detecting the missing pill. The second application you can see here, let's assume it's some smart mart, it's a mart, shopping mart. Now again, I have trained a model that will be able to tell me that a certain product is missing from some given shelves, right? From, for example, here this packet of biscuits is missing here. Again, here something is missing. These these cheese packets or some things are missing. Now, by using this particular model, what I can do, suppose I'm a store manager and I'm able to, I have some cameras installed in my store, right? And from that cameras, I got this information that, okay, that particular shelf of biscuits is going to empty soon, or is going to sell out soon. So I will be able to manage my things in such a way that before the complete shelf is out, I will be able to fill it up again with biscuits or the equipment or the things that are present there. So in this way, I can again take advantage of AI here for, let's say, what we can say, for supply chain management. It's not exactly supply chain, but yeah, for now, to understanding this particular thing. So that particular thing I can do. One of the example is detecting the weed inside the microbes. So unwanted plants, I will be able to know that if there is some unwanted plant is present or not. So a drone can be used here. A drone having a camera, and inside that camera we have deployed our AI model that is able to detect weeds. Now by using that, if I'm a farmer, I will be able to know that inside my, let's say, 50 acres feet, where is weed present and where I need to spray the pesticides. So again, taking advantage of our AI here. Next one is your text detection. By using object detection models, again, we will be able to detect the boxes that have some text or in the warehouse or something. And again, on these particular boxes, we can use OCR for reading the text itself. That again is a different topic of discussion. And the last one is an example of rust detection. Now, for say we have some construction thing or some building or something, and we have to detect that whether there is a rust or not. And on the quantity of rust, we will be able to know that this particular thing needs painting or not. So that thing we will also be able to do by using object detection. Right. I hope all these basic examples are clear to you all. Right. You can write your responses in the chat section so that we can move on. Okay, great. Now let's get a little bit deeper in object detection, how exactly object detection works. So classification, I hope, is clear to all. So object detection is nothing but a one step ahead of classification. So first of all, let's assume that I have an image that is having multiple objects, or that is having one object. Let's take the cat image only. I have this cat image here that is having this cat object there, right? So what object detection will do? First of all, it will classify that whether a cat is there or not. If it is able to classify that, okay, cat is present there. So our first task is over. Now the next task is localization of that particular cat. So in the image, where exactly that cat is present, what are the coordinates of that particular cat, right? That thing also happen in object detection. So basically it will draw a bounding box across the cat so that I will be able to know that, okay, if my image is this, my cat is present in left corner, right corner, center, or where. And if multiple objects are also present, it will draw different bounding box across all the multiple objects. So classification plus localization is your object detection. So how the input and output will look like. So here you can see in the slide, it's just mentioning the same thing that I told. Locate the presence of object with a bounding box, right? And type or classes of the located object. So classification is also happening as well as localization is also happening. So let's assume this is my AI model that is AI model for object detection. So my input image will look like this, right? Again, this is nothing but data in the form of matrices. Image is nothing but data in form of matrices. I put this particular data inside my object detection model, and it gave me out these type of output. It gave me that what is the class of the object. It is telling me that, okay, a cat is present at this particular location or at these coordinates, and one dog is present at these coordinates, right? So these coordinates are nothing but your upper point and lower point of your bounding box. This is one of the format to represent your bounding box, right? So once I have this upper point and lower point, I will be able to draw the bounding box across the image. So it is telling me that, okay, one cat is present at these particular coordinates, and the dog is present at these particular coordinates. So my input will be this and my output will look like this. And by using this particular output on my input image, I can draw these type of bounding boxes, right? So this is object detection in brief. How exactly it started? So classification thing is clear to all. So the first, or we can say that how exactly it started. So if I have a bigger image, for example, this is my bigger image, what exactly is happening in object detection is a sliding window is going on through small patches of the bigger image, and it is trying to classify, or it is trying to find this particular object of interest, that is my car. So at different patches, different sliding window traveling area, it will tell me that, okay, here no car is there, no car is there, no car is there, again no car. And at last, whenever it will find a car in a particular frame, it will tell me that, okay, car is present there. This is a brief idea that how object detection started, right? So crux behind the object detection is this particular thing only, classification, but at small frames of a bigger image. And after using multiple different methods on them, after some of the post processing, we will be able to get the object detection boxes. Now let's talk about our topic of today, RCNN family. So these RCNN families, these are basically the models, various models, predefined architectures that are used for object detection, right? So some of the models are already present there, those that are kind of developed by some researchers in AI field that perform well on object detection. So one of the set of these particular models is RCNN family. So RCNN stands for your reason with CNN feature, or region-based convolutional neural networks. So I hope all of you guys knows what is a convolutional neural network. Main application of CNN is in this computer vision field only. So basically getting the features out of an image, right? So if I show you, this type of thing is your convolutional operation. So if we have, let's say, one image here, this is particular image, just imagine this is an image. So on this particular image, a small matrix or a small convolutional kernel will be run, and it will try to extract the feature out of this particular image. Now there will be different kernels there that will get different types of features, extract different types of features. It can be your corners, it can be your straight lines, it can be your pointy edges. So different kernels will be there, predefined kernels inside any given network, right? So by doing this, we are doing the feature extraction from our original image. We are getting the feature map. And once we get the feature map, again, feature map is nothing but data, right? Your encoded data from the image that is containing useful information of that particular image. Now that particular data will be passed through your models, your ANN models, or CNN, simple neural network models, not ANN, simple neural network models, right? And your model will be trained depending on your need. So this is and your some of the features of your RCNN family networks are, these are two shot detections. So basically your RCNN models works in two shots, or does work in two iterations. So first shot or first stage is your CNN network that will extract the region proposal, or that will extract your feature maps, right? And once we have those feature map, a second CNN is used that will classify and localize the object, right? So two stages are there. You will be able to know what exactly these two stages are once we go on further and see the images, how RCNN or faster RCNN structures look like, right? So the first member of this RCNN family is your RCNN. That is the granddaddy of faster RCNN, right? So how exactly this RCNN network works? So this RCNN network works in 3 steps, right? So the first step is it will scan the image that I have provided, right? It will scan that particular image for possible object, right? For example, I have provided it an object, an image there, right? Let it be an image. So it will scan the complete object, complete image, and we'll see that if in a certain region an object is present or not. And that it does by using this particular algorithm that is known as selective search. By using this selective search, it will generate around 2000 region proposals. Sorry. So basically, it will generate 2000 regions of interest inside my image, right? How will it work? Let's see once, right? So for example, I have this particular input image, right? So what exactly this selective search will do, or first step will do, it will make us segmentations for each pixels here in this particular initial image. And this particular segmentation or initial sub-segmentation will be generated. So our segmented part of, or our segmented image will look like this. All the different areas having different colors. For example, this lady's hair is having different color, eyes is having different color. So all this particular image is converted into initial segmentation. And once we get this particular segmentation graph, now the next step will be recursively combination of smaller region into larger one. So these smaller regions will be combined together with the larger one. And the algorithm known as greedy algorithm is used to combine similar region to make larger regions, right? So how does this greedy algorithm works? So from the set of region, these are different set of region, right? It will choose two that are most similar. For example, here these two regions are most similar, and they can be similar due to their color, due to their texture, or due to their fill. So it will choose the region that are most similar, and after choosing these region, it will combine them into a single larger region, right? And again, it will repeat the two steps that I mentioned again and again for multiple iteration. So after so many iterations, we will be able to get these region proposals, region of interest. Now these region proposals, once we get these region proposals, and around 2000 region proposals are generated in RCNN. Once we get these region proposals, a convolutional neural network, a CNN, is run on top of these region proposals to extract the features, to convert these region proposals into feature maps. And once we get these feature maps, now these feature maps are further transformed to an SVM, spot vector machine, that will classify the region, that whether there is object present or not. And if there is object present, then a linear regressor will tighten the bounding box, tighten the bounding box coordinates there if an object is existing there, right? So first of all, what happens? Image is passed, 2000 regions of interest or region proposals are made from that. After that, those region proposals are passed to through this CNN feature map that will get the features get the feature maps here. And after that, these features maps will be passed to one your SVM classifier to classify that whether there is a class or not, and a linear regressor will be used for tightening the bounding boxes of that particular object. So in this way, your RCNN network will work. And here is the complete flow of the RCNN network in this particular image. So this is my input image. From this particular input image, region of interest were formed. Around 2000 region of interest are formed. And on these 2000 region of interest, 2000 convolutional neural networks are used for extracting the features, right? And after getting these 2000, and on these 2000 neural CNNs, again, different SVMs and bounding box regressors are used. So RCNN was initiative, but was very slow. Why? Why was it slow? Because first of all, we are running 2000 CNNs, right? So there will be a lot of computation there. So one of the reason was that, and second reason was this selective search is also slow. What about detecting object where bounding box overlap? So for that particular region, NMS comes into picture. That is your non-max separation. Now, the next member of the family that came into picture is Fast RCNN. Now, RCNN, just immediate after RCNN came Fast RCNN. So it was similar to the RCNN, but it has two different or two modification. First modification was, as I said, 2000 convolutional neural networks are used there. So a lot of computation was needed, or a lot of computation time was needed. So what happened in Fast RCNN? What exactly the researcher did, that instead of using 2000 CNN, first of all, we will make the feature maps from the initial image itself. And once we get the feature map, we will run our region proportional network, or we will run our selective search on the last feature map. So instead of using 2000 CNNs, our work will be done from one CNN only, right? If I show you here, and the other modification was, instead of using SVM for classification, a simple softmax layer is put at the last of your CNN. So directly complete a neural network will be there. So your neural network is extended instead of creating or using a new SVM model, right? So here, if you see the structure of Fast RCNN, in RCNN, what was happening? Initially, ROIs were we were getting the ROIs by selective search, but here in Fast RCNN, first of all, we are running a convolutional neural network to get the feature maps, and once we get the feature maps, on that feature map, last feature map itself, we run our ROIs, or we run our selective search on our last feature map, and from that selective search, we will get our region of interest, and these region of interest are then passed to a softmax layer that will directly tell me that, okay, whether an object is present or not, or what is the class of that particular object. And again, your bounding box regressors are present there for doing their job. So this helped in increasing the speed. But again, there is one big bottleneck remaining, that is your selective search algorithm for generating region proposals. We are generating 2000 RPNs, right? 2000 region proposals. That again is itself highly computationally heavy. So for solving this purpose, our faster RCNN came into picture, right? Now, what happened in faster RCNN? So mainly difference or advancement, modification of this faster RCNN was replacing the slow selective search algorithm that we just talked about with a faster neural network. And it introduced this region proportional network, RPN. So basically this RPN will get me the region of interest, right? And how does this particular RPN works? Let's see in the image instead of reading here. So from my last convolutional feature map, what will happen? A three sliding window will be run on my last convolutional feature map. And for each point on my this 3x3 sliding window, I will generate K anchor boxes. So anchor boxes are nothing but your area. Is RCNN classified as semantic segmentation algorithm? Yeah, you can use it for semantic segmentation as well as object detection. For both, you can use it, RCNN. So for each area, anchor boxes will be generated. K anchor boxes will be generated, and now these anchor boxes will be of different orientation. One can be a tall box, one can be a wide box, one can be a large box, and for each of these boxes, we output that whether or not we think there is an object present, right? And if there is a present, what are the coordinates of that particular anchor box? So these random anchor boxes will be generated for each point inside my images, and on those anchor boxes, this particular anchor box, a classifier will be run that will tell me that, okay, if an object is present there or not. So basically we are just, this is the first stage. So we are just telling that, okay, in this particular region, an object is present or not. We are doing nothing else. So if an object is present, we will take the coordinate of this particular anchor box and pass it to the second stage, right? Now here you can see K anchor boxes will be generated, and now these K anchor boxes will be passed through one of the classifier layer, and regression layer is nothing but the these coordinates of these regression anchor boxes itself. Me scores. So basically 2K scores will be generated whether an object is present or not. That's why 2K scores. And 4K coordinates are generated, upper limit coordinates and lower limit coordinates. Now, and again, one important point here, that RPN outputs bounding box coordinates, these particular bounding box coordinates. It doesn't try to classify any potential object. Its main job is just to tell that whether and if it thinks that inside the anchor box an object is present or not. Or that we can again say by the objectness score, right? And if that objectness score is above a threshold, above a certain threshold, that particular bounding box coordinate is passed to the next stage, right? Does the presence of object refer to the presence of class? Yeah, Ashok. Basically, if we talk about it initially for understanding this, let's assume that I have only one class. I have only one class, and that is my object itself. But again, if there are multiple classes, so there will be multiple output from my classifier layers, right? Probability of presence of each class. Now, once I get the objectness of each anchor box, and I know after applying the threshold, I will get the final anchor boxes where my RPN thinks that object is present. Now, that particular RPN or those particular regions are passed to my last layer again, where a classification and bounding box regression is happening the same way it was happening in Fast RCNN. So once we feed our region proposal, we feed them straight into what is essentially a Fast RCNN, right? Basically, if we see, so your Faster RCNN is nothing but Fast RCNN with a region proportional network. So this RPN is added inside your Fast RCNN, and your Faster RCNN is present there or is made. So core design of your Faster RCNN is same as that of original RCNN, right? First of all, seeing or getting the regions where we think that object is present. And once we get the regions, then we classify them or tighten our bounding boxes. So these are the two stages. First, getting the region of interest. After that, classifying and tightening the bounding boxes. And all your three members of RCNN families work on this principle only. Now, a summary or a comparison of these models, right? So what will be the time? What will be the test time per image for RCNN? So if an RCNN is taking 50 seconds to run inference on one particular image, your fast RCNN will do the same job in 2 seconds, and your faster RCNN will do the job in 0.2 seconds. So you are able to see how fast your faster RCNN is from initial RCNN, right? 250 times faster. And these are your MAP scores for each one of them. Fast RCNN, faster RCNN kind of have similar MAP. So there is not much change in the MAP, but your speed is changed. MAP is basically a matrix used to what we can say, used to tell how good my object detection algorithm is, how good my object detection model is. So yeah, this was all about the theoretical part. You guys have any question on this, you can write in the chat box or Q&A section. Then we will go on to our pipeline. Hello. Or you can write in the chat box that you are able to understand or not. If you have any questions, that again you can also put. Okay, so I hope you guys don't have any questions. So let's start with the pipeline. Now is RCNN can be used for medical use cases, as you showed that MAP is 66.9%. That is of again, that again depends. You have to train your RCNN again on the images that defines your application, and after that you can check this MAP. The MAP that I showed is for COCO dataset. So yeah, so first of all, we will talk about the pipeline. So basically, using Jupyter notebook is good, but instead I will say that make an habit to make the pipeline out of that particular Jupyter notebook. Is RCNN better than ANN? As in RCNN is basically used for object detection, and obviously the same questions goes to for you. Is CNN better than ANN? Could you please explain difference between YOLO and RCNN? So basically in YOLO, what happens? YOLO is your single short detection. So all the things that the region proposal thing is not happening there. Directly YOLO will do in the first stage itself. It will see that whether there is object or not. And if there is object, it will directly do the classification and the regression of the bounding box there. That's why YOLO is a little bit faster than RCNN. But yeah, that compromises with the MAP. Our data set is the MAP based on COCO data set. Mayuk. Okay, so let's talk about the pipeline. So yeah, I was telling that instead of using Jupyter Notebook, try to make a habit to get a pipeline or create your own Python scripts there. So what will happen? You will need not to run all the cells of Jupyter Notebook again and again. You can just run one Python script and your training will start. So for example, here, this is the pipeline of RCNN that I have made look like. In outputs, your output model or trained model will be there, and your plots of training and testing will be there. In test and train, your training data, your training images with Pascal VOC format annotations will be present. That will be present here. And in SRC, my Python files are present. Right, my Python scripts are present. So let's talk about these scripts. What does these scripts does? So first script is my configuration script, configuration.py, where all my parameters that I can change, my hyperparameters, and different things that are changeable in nature, that particular thing will be written here in configuration script. You can see I have written best size, resize, in basically the size that which I want to resize the image for training and transform, number of epochs, for how many epochs I want to run the model, device, which device to use, GPU, CPU, or whatever, that again you can assign, training directory where my training images and XML files are present, testing directory, again classes, what are the different classes for my data set, number of classes, again you can mention. This one is for one of the function that I have written inside my pipeline, output directory where to store my save models or plots. So here I want to store inside my outputs. Save plot epochs and save model epoch, after how many epochs you want to store the model as well as plots, right? So all these configurations files or all these changing parameters can be written here in configuration.py. So you just need to change the parameters here and run your engine.py. In dataset.py, basically I am creating my data loaders. So for example, if I want to create a data loader, data loader will be basically an object that will pass each image. Image is basically your feature values, and labels will be your coordinate values. So it will pass these features and label value to your model while training. So all that particular thing is written here. I will not go in depth that what exactly is happening. It is basically reading an image, and after that reading an annotation for that particular image and combining them both so that it can further pass to my model. And I'm using data loader object of my PyTorch here for creating this data set loader, right? In engine.py is my main file where my training will start. So before going on in engine.py, let's see other files. Model.py, I'm loading the model, right? So I'm using my Fast RCNN model from my Torch Vision. So that model is generated here. Here it will pass just how many total number of classes are there for my application. So it will pass that. I want to use pre-trained model or not. Pre-trained by default, it is trained on COCO dataset and ImageNet. Model.py is there. Utils.py are basically some of the functions that I am using. or utility functions that I'm using inside my engine.py. Inference.py is basically a function that I've written, or a script that I've written for running the inference over a new image. And in engine.py, my training is taking place. So I've written a train function that is just that is taking my dataset loader that I have created inside my dataset.py, and after that it is running the images and target from that dataset loader through my model, and my training is happening, right? As I'm using my PyTorch model, so my optimizer is also present there. Optimizer.step I'm using here, and all the information is stored inside a list that I will use for generate my plots, right? So here, for example, I'm using SGD. Averager is again a function that is present inside utilities.py that I'm using here. And training iteration, it will tell the total number of training points, right? And complete training will go on from here. So in this way, if I have to train a new model for different hyperparameter, I just need to change them in config.py, and I just need to run this engine.py. So my new training process will start. So always try to do this training process like in this format only. So yeah, this was all about this pipeline. We didn't go in depth because it again will take 4 to 5 hours for understanding the code. But yeah, it was an overview of the pipeline. So I hope it is clear to all. Any question, guys?
Guys, you can put your questions in the chat section or in the Q&A section if you have anything to ask.
Yeah, this is for custom training. So basically, you need to put your data set inside your training and testing set. Yeah, I will share my GitHub profile and my LinkedIn profile. So you can connect with me on my LinkedIn here. Okay. This is my LinkedIn profile.
Yes, sir. I also have it. So you can share the GitHub. I'll share the LinkedIn profile.
And this is my GitHub. You can find various projects on my GitHub itself. And also we have this initiative that Rishabh already told, Petroleum from Scratch. You can also follow our YouTube channel there if you want to learn new things. There again itself, we generally talk about data science, AI, and ML. Its just name is only Petroleum from Scratch, but we talk about data science only.
Okay. So no more questions, guys. Okay. So before we take more questions, I have started a feedback poll for you guys. Please check it out and give us the feedback, as it is important for us to conduct more such sessions. Sir, there is a question in Q&A.
Yeah. This topic is new to me. Can you suggest a pathway to master the topic? So basically, whoever is asking this question, do you have an initial idea of how machine learning algorithm or simple data science algorithms, or the complete thing is new to you? The complete thing is new to you, then you can just start with Python, go on from statistics, followed by initial shallow learning techniques, then deep learning, and after that go to computer vision. But yeah, if you have an idea and you want to come into computer vision, then just start by that, okay, how basic classification, image classification works, and after that how object detection works, the same process that we discussed in our starting of the presentation.
Okay. So I suppose we are done with questions because I can't find anything. So shall we conclude, sir?
Yeah.
Okay. So thanks a lot, Jaiyesh, sir. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. I am sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Yeah. Thank you all for attending the session. I hope everybody gained knowledge from the session.
Yeah.
And
Shortly they did. So I hope you guys have filled in the feedback poll, and if not yet, I request you to please fill in the poll about the feedback, as it helps us to conduct more such sessions. If you wish to conduct a webinar or facing any difficulty in registering any of our upcoming sessions, connect with us at datahour@analyticsvidya.com. You can find this in the chat section. The recording of this session will be available on our YouTube channel. And for that also, the link is there in the chat section. We have a few upcoming sessions. There are 2 sessions tomorrow and day after that as well. So you guys can check that out. All the links are there in the chat section for you to check. We'll be back with another session of the data tomorrow. And there is another session at 8:30 as well, today 8:30 p.m. So till then, please keep learning and bye-bye. Thank you so much.